Hello and welcome to Ambassador Energy online training. Today we are going to talk about basics of PV applications. So this is our introduction to PV. We're going to touch very lightly on each of the subjects, and there will be plenty of other trainings that we will do that will go into more detail on each of these subjects. So today's just a basic overview for people getting into the industry or just want to know more about the industry. My name is Catherine Kelso. I am a NABCEP certified PV installer and have the NABCEP certification for PV technical sales as well. And if you want to find out more about our training classes, you can go to www.ambassadorenergycollege.com. So the first thing we're going to talk about is why do people want to go solar? And there's been a lot of things going on in the last few years that has really brought this industry out in the U.S. It's been a lot stronger industry in Europe for the last few years, but the U.S. is finally starting to pick up the pace. And it's one of the few growing industries in our current economy. So the things that are currently driving the industry, number one is the 30% federal tax credit. And what that is, it's an actual tax credit for 30% of what you pay for any solar power system. So what happens is, you go out and you spend $10,000 on solar equipment. You get $3,000 off what you owe in federal taxes for that year. If you spend $30,000 on solar equipment and having it installed, you get $9,000 off of what you owe in federal taxes. And this tax credit is for residential systems and commercial systems. So basically, anybody at all that goes to install solar gets 30% off of what they really had to pay for the solar because they get this tax credit. And you have time to roll it over into future years if you can't take the full credit in one year. But all in all, most people can take that credit and they're perfectly happy to take that credit. And that has been keeping the price of solar to the point where customers see quick payback on it. So the federal tax credit has been a very important part of all this. Now, another thing that's been going on is state and local rebates. And this is in several locations. There are still some states in the U.S. that don't have any kind of solar incentives. And in those states, there's generally not too much solar getting installed. But there are lots of states that have very, very good incentives to do solar. Some of those incentives are tax credits, like up in Oregon. Some of them are what they call feed-in tariffs, like what they have in Ontario, Canada. And a feed-in tariff basically means that they will pay you for the kilowatt hours that you produce from a solar power system. And then in New Jersey, they're doing what they're calling trading renewable energy credits. So basically, your system produces renewable energy from solar, so it's good, clean energy, and you can go and sell those kilowatt hours on the open market for a much higher price than you pay for regular electricity. And then some states like California have rebate programs where you put in a system, and a couple months after the system's installed, you get a big fat check in rebate money, which is a few $1,000s. And some states have higher rebates than others. Some states, have rebate programs that get funding and then run out of money and then get funding again. And, there's lots of different flavors of rebates and incentives. And some local places, like certain cities, for example, the city of Murrieta, California, had a $1,000 rebate for anyone who put solar in, didn't matter how big the system was. And little things like that. A lot of little cities have their own rebates and that kind of thing to encourage people to put in the renewable energy. So that's another thing that's driving the industry. A third thing, which actually kind of goes back to the tax credit thing, on commercial jobs. So anytime someone's putting solar in for a business, they can do what they call accelerated depreciation. Now, solar power systems in general are expected to last at least 25 years. The solar panels have a 25-year warranty on them. So that's we're expecting that kind of life expectancy out of these systems. So when a business installs a solar power system, technically, according to the tax law, they should have to depreciate that over 25 years, which means it's going to take a long time for that to get money off their taxes. But what the government has done for us is put in what they call accelerated depreciation. Now, for a little while, you could depreciate your entire system in 1 year. That has gone away, but you can still depreciate it over 5 years instead of the full 25. So basically, a business that installs solar power not only gets this federal tax credit, They also get whatever state and local rebates there are. And then finally, they get to depreciate the system over 5 years instead of its 25-year lifespan. So basically, they're getting extra incentives for the commercial jobs to get done. And part of the reason for that is, the businesses are the only ones that do depreciation. Regular homeowners don't do that, so it's not something that they could give them as a tax break for solar. So the accelerated depreciation for commercial solar has encouraged a lot of businesses, especially between the 30% tax credit and the accelerated depreciation. A lot of businesses are suddenly wanting to put solar in because they can see all the incentives. And with all those incentives, it ends up being a very quick payback for the price of the system. Another thing that's happening right now, and this has been going on for the last couple of years, is low solar panel costs. Solar panels cost a lot less now than they did in the past, and we get a lot of customers that say, oh, I looked at solar before and it just didn't make sense. It didn't pay for itself quickly enough. It didn't really, offset enough of my electric bill to justify the cost. And we say, you know what? If you got that quote a couple of years ago, let's look at it again. Solar panels pricing has come down quite a lot. And a lot of people that it didn't make sense for them to go solar 3 years ago or 4 years ago, suddenly it makes sense now. So we're seeing a lot of customers that, previously said no because the price was too high, now are looking at the current prices and saying, that looks like a little bit better deal now, and I'm going to get my payback faster because I have less money to put out for that system that's going to generate so many kilowatt hours to save me on my electric bill. So that's another thing that's been driving things lately. And then finally, of course, you've got the warm and fuzzy feel good. It is good for the environment. The proposals that we show customers show, you're offsetting this many cars on the road, and, you're taking this much CO2 out of the atmosphere and all that stuff. And, customers a lot of times are looking at the cost and the payback, but, everybody wants to do what's right for the environment and do the feel-good stuff too. So that's definitely helping the solar business as well. I've had plenty of customers that were in areas that didn't have tax credits or rebates locally, and their electricity was really inexpensive, so a solar power system really wasn't going to pay for itself. But they went ahead and bought it anyway because they wanted to be environmental. They wanted to reduce their carbon footprint, and they had the money to do it. They didn't care how fast they got their money back, and they put in their solar panels. And there's absolutely nothing wrong with those customers. That's how they want to do things. We'll happily sell solar to them all day long. So good for the environment is not necessarily the first reason people think about when they want to put in solar panels, but there are plenty of people out there that will put in solar panels solely for that reason. So that's the reason why people are going solar now. So let's talk a little bit about how these systems work. The most of what we're seeing in solar these days is grid-tied solar. And by grid, I mean the utility company. So we're taking homes and businesses that are already connected to the electric company, already getting power from the utility company, and we're putting in solar to offset their electric bills. And the way it works is you've got your solar panels on the house here, and the sun hits those solar panels, and they generate DC electricity, just like what a battery gives you, DC power. Not exactly the same volts as a battery, but it is DC power. And that goes to what we call an inverter, which usually hangs on the side of the house. Sometimes it's inside the garage, wherever it happens to be. It goes directly from the solar panels to the inverter. And the inverter converts that DC power to AC power. Then we have wires that run from the inverter to the AC electric meter. So the house's electric meter, the meter that spins that the electric company comes out and reads and uses to bill you, and your main electric panel. That's where the inverter has its own dedicated circuit breaker inside that main electric panel, and that's how the inverter feeds power to the house and to the grid. And the way that works is when the sun is shining, it's during the day, if you are using power in the house, you are using solar power. So whatever's on in the house is running off solar power. And a lot of times you're actually generating more power than you're using right at that moment because, a lot of times people aren't home, the kids are at school, the parents are at work, and nobody's there to be using that power. So, it's feeding whatever load you have. Usually the air conditioning's on still slightly, the refrigerator's running, all that stuff. And then the excess power that it generates is actually fed to the electric company and literally does spin the electric meter backwards. So you're getting credit for those those kilowatt hours you're feeding the electric company during the day. Then at night, when the sun goes down, now your solar panels aren't generating power anymore. And so you're going to pull your power from the electric company and spin the meter back the normal way. And so what happens is at the end of the month, they'll come out and read the meter, and if you have used more electricity than you generated, they will charge you for that electricity, just as they always have. And that's usually the condition that most systems are in. We usually don't size systems to generate more than the house uses. So, you pay the electric company for that little bit of power you needed from them. Now, the other way that it could happen is you generated more power than you used. And depending on how the electric company wants to handle that, and that's something that's determined in what they call the net metering agreements, which is a contract between you and your electric company. You basically say, yes, I'm going to put solar power in at my house, and I need to, have a contract with the electric companies, working out all the details of how, they're going to pay me for that power or give me credit for that power or whatever they're going to do. And it's different from electric company to electric company. Every state has different rules about it. There's a lot that goes on there. Some electric companies, if you generate more power than you use, they won't pay you back for it. Other electric companies will pay you a wholesale rate for it. Other electric companies will pay you a little bit more for it. But in general, we're trying to size the system so that the customer is offsetting the home's use minus a little bit, so that we don't have that situation where we've generated more power than the house used. Unless you're in a location like New Jersey or Ontario where they have feed-in tariffs and they will buy renewable energy credits from you. In those cases, we're going to put in as much solar as we can, because it doesn't matter if the house uses it all. It's worth more money sold on the open market or going into the grid for the feed-in tariff. So those are different situations. So the situation is different in every state depending on what the rebates and that kind of stuff are going to be. But in the end, if your solar is generating more than you use, it gets fed to the grid. And if you are needing more power than your solar is generating, whether it's during the day and you've got your air conditioning kicked on full blast and a very small solar power system, or it's nighttime and the solar isn't doing anything at all, you're just going to pull that power you need from the electric company and they will bill you for that. So, basically there are no batteries in these systems. And one of the things about not having batteries in the system that gets a little sticky is that when there's no batteries, there is no power during a power outage. And this is a common thing that happens a lot, and people don't understand it, and their solar installer doesn't explain it to them. And when they come around and get the first power outage after their solar's been installed, and their lights go out, even though it's daytime and the sun's out, but they have no power in their house, they get upset because they assumed that the solar power system would still feed their house with power during the day, even if the power is out. But that's not how these systems work. And it's actually a way that they build the inverters, and it's the way that they're required to build the inverters in order to get what they call the UL listing. Everything that's going to be installed on a house that's electrical has to be UL listed. So part of the requirements to UL list a PV inverter is it has to shut down during a power outage. Now, it doesn't sound like it makes a lot of sense until you stop to think about it from the electric company's perspective. If the power is out, they've got workmen out working on the lines trying to find the problem and fix the problem. And if they're working on those lines need to be dead. There needs to be no power being fed to them. But if you have a solar power system and during the power outage that solar power system is still feeding power to your house's main panel, there's nothing to stop it from feeding it out to the grid and shocking those linemen that are out there trying to fix the grid problem. So it's a safety thing for the electrical workers. So there's really no way around it. The equipment does what it does because that's how they designed it. And during a power outage, there will be no power in the house even if the sun is shining, unless you do a special kind of system that has a battery backup. And, it's really complicated how those get hooked up to avoid feeding power back to the grid. They typically only feed a certain few emergency loads that the customer designates as these are the loads I want. These are the things I want to be able to turn on when the power's out. A lot of people want their refrigerator to still be on. Other people want to make sure they have lights and TV. And they may not care so much about the hot water heater or, other loads like the air conditioning. May not be that big of a deal to have that on during a power outage. But we don't do too many of the battery backup systems, mostly because they're pretty expensive. So the cost of those doesn't really justify the use. It's one of those things where when talking to customers, usually you tell them, because you want to be upfront with customers about stuff. And I always train salespeople to let them know about the power outage thing ahead of time. Because the last thing you want is angry customers that have already got their system installed that thought it would do something that it's not going to do for them. So when you tell a customer, okay, when the power goes out, you're not going to have power, usually the next thing out of the customer's mouth is, well, I want power during a power outage. How do I get that? And the answer to that question is, well, you have to buy the battery-based system, and it's going to cost this much more. And typically that cost can be anywhere from $6,000 to $20,000, depending on the size of the system and what kind of stuff they want to run during a power outage and how long they want to be able to go without power and that kind of thing. And most customers, when they hear those numbers, suddenly don't care about power outages that much anymore. When they're looking at their return on investment and how much money they're going to get back and how quick the system's going to pay for itself, putting in the battery-based system really throws that out the window. Now, with that said, there are plenty of customers out there that will pay that extra money. There's people that, they call them the doomsdayers, where they think, something's going to happen and society's going to fall apart and they want to be self-sufficient. Nothing wrong with that. I've sold lots of equipment to people like that. And, maybe I'll go knocking on their door if that does happen, because I know they've got electricity. But for the most part, the average homeowner, once they find out that backup power costs that much more, they go back to just, I just want a regular grid tie system that's going to offset my electric bill and give me a good payback and return on my investment. And that's the end of the conversation. If they do want a battery backup system, then it's a matter of finding out what loads they want to run, and there's a lot of more complicated system sizing that goes on to make sure that you get them the right equipment to do what they want it to do. So that's the basic on grid tie solar. Now we're going to talk about what goes into a solar power system, the basic components. And solar power systems can be reduced to 3 basic components, just 1, 2, 3, simple as it gets. You need solar panels. You need that inverter, because remember the panels give you DC power, and you need an inverter to change that to AC power so you can feed the grid, which is all AC power. And then the balance of system stuff, which we often call BOS. And that's all the extra little things that you need to make this work. And so we'll go over each one of these one at a time here. Now, solar panels themselves come in a few different flavors, is what we call them when we're talking about it. But there's just a few different types of solar panels. And of these different types, there's tons of brands that come out with all these different types. So the basic types of solar panels are monocrystalline and polycrystalline. And between these two types, it's roughly about 95% of the solar being installed is either polycrystalline or monocrystalline panels. The official textbook term for these panels is flat plate PV collectors. Never have I heard anybody call them flat plate PV collectors outside of a classroom textbook or on a NABCEP certification test. But that is the official textbook word for them. Most people call them solar panels, PV panels, or solar modules, or PV modules. Now, PV, we haven't discussed this yet, PV stands for photovoltaic, which really I always say that's the fancy way to say solar electric. But it does differentiate between solar electric and solar thermal. PV is panels that generate electricity from sunlight. Solar thermal generates heat from sunlight, so it's an entirely different kind of technology. So we're talking about the electricity stuff here, the solar electric or PV. So when we say PV, we're just trying to differentiate, because if you just say solar, it could be solar thermal or solar electric, you don't know. So that's the PV part of it. And then these are either going to be called collectors or modules or panels. And the difference between polycrystalline and monocrystalline really isn't that much. It's how the cells are actually created, and we'll go into that into detail in other trainings. But you can see that the monocrystalline cells, they actually start off round, and so they cut off the corners of them and sort of square them off. And then you end up with these little diamond shapes between all the solar cells, which these are all, each one of these little blocks is a solar cell. And this is the solar module, which is a bunch of solar cells connected together. And so you can tell a monocrystalline solar panel from these little diamond shapes that are in between all the solar cells. Now this here is a polycrystalline panel. And this also has individual solar cells, but they're perfectly square. And they're placed in the panel right next to each other, so you really don't see the spaces between them. These white dots is really just the white backing that the solar panels are laid on. but that's why you see those dots between there. These are all square and there's no space between them, so it doesn't look like the same as the monocrystalline. So you can instantly tell when you're looking at any solar panel whether it's mono or poly just by looking at it. Now there's not too much difference in performance between these two. It used to be that monocrystalline was actually produced more power and worked better under low light conditions and that kind of thing. But over the years, they've come a long way with the polycrystalline technology, so the efficiency of the actual solar modules themselves is almost exactly the same. And at this point in the industry, we sell poly or mono just not randomly, but more based on what our supplier has in their warehouse and what they're going to give us a better price on than what, saying that monocrystalline does better than polycrystalline or polycrystalline is, not as good. And that's just kind of been, over the last few years, the technology of polycrystalline has gotten a lot better. 10 years ago, a monocrystalline panel would really perform better than a poly. Nowadays, they're pretty much equals as far as, output and performance and efficiency and that kind of thing. So in the end, there's not too much difference between mono and poly other than the way they look. As far as the way they perform, they're almost exactly the same. Even their data sheets and specifications are often the same from mono to poly. If you're looking at the same brand of panels and they have a 240 watt mono panel and a 240 watt poly panel, they'll have the same, almost the same voltage and current, amp output as the other ones. So there's really not a huge difference between those two. Now, like I said, these two types of panels, mono and polycrystalline, which we call standard racked panels, they've got an aluminum frame. They're covered in glass that's about as strong as a car windshield. And you install them on racking. So we call them standard racked panels. That covers about 95% of the U.S. solar industry. The other small portion of the U.S. solar industry is thin film panels. And thin film panels are having a little bit of a hard time in the market these days. A lot of these companies are going out of business. Part of the reasoning is thin film used to be a lot less expensive. You needed less silicon to get the same amount of watts. And silicon was the expensive part of the solar panels. A few years ago, the price of solar panels pretty much shot through the roof because there was a supply and demand issue with the silicon. And so a lot of manufacturers found ways to make solar panels using less of the silicon so they could make them much less expensive. And it went very well for a few years when the standard racked panels, the regular PV modules that we're used to seeing, got very expensive. And then they had these thin film devices that were much less expensive. They sold a lot of them. Now the price of the standard panels has come down so far that it's actually very difficult for thin film to compete. And for also a variety of other reasons, including just the general economy being low, these companies aren't doing very well. But we're going to look over some of these examples because some of these things are pretty cool. And even if these companies have gone out of business, I'm still hoping some of these patents get picked up by other companies and this stuff gets created because some of it is pretty interesting and pretty useful. This one here is a unisolar panel, and it's actually flexible. You can see it rolled up here. It is 100% completely flexible, and it's designed for what they call standing seam roofs, where you have the seam of the roof. There's a seam that sticks up a few inches every 1.5 to 2 feet on these standing seam roofs. And this becomes a little bit of a challenge to figure out how to install regular racked panels. But these are designed to just fit right in between those seams up and down the roof. And as you look at it, there's nothing, you don't see any racking or anything. What this is actually held on by is an adhesive back. These literally, we kind of laughed when they first came out. We called them peel and stick solar. And, we all had a good giggle over it. But I've installed these, and you know what? They're really, really easy to put in. You basically get them set up in the right position and then peel that backing off and literally glue them down to the roof. So that's unisolar. Another one, this one has gone out of business. It's the Soleil tiles. And basically this piece right here is designed to go in place of a rounded S-tile, those clay tiles that you see on a lot of roofs, especially in the Southwest and in Southern California. They call them S-tile, and they're curved tiles. And this is designed to go right in with those curved tiles. And whenever you're doing this kind of stuff where you're actually replacing building materials, because now I don't need those roof tiles anymore, I'm going to use the solar instead, they call that BIPV, which stands for Building Integrated Photovoltaic. So I'm actually integrating my solar panels into the building design and using solar panels instead of roofing material. Now, I think part of the reason these people went out of business is most clay tile roofs are red or brown, and these things were kind of a bright purpley blue color. They probably would have looked really good on an IHOP, but they didn't look that great on a regular red roof. They stuck out pretty bad. And they were a lot more expensive, too, than regular solar panels. Another one that also went out of business is Solyndra, but I want to talk about this one because it was a very smart design. One of the things we have issue with in the solar business and with solar installs is wind load. If you've ever carried a big piece of cardboard or a big piece of plywood on a windy day, you can feel the wind pulling you. It's like having a big sail in your hands. And the same thing goes for having solar panels on a roof. They are like a big sail, especially when they're all connected together on the racking. And what can happen is the wind can get up under the panels on the roof, and they call it uplift pressure. And so basically the wind is trying to rip those panels up off the roof. And we have to make sure that they're bolted down to the roof rafters, and we've got plenty of attachment points and everything. There's a lot of engineering calculations that go into figuring out how well it has to be bolted down to the rafters based on how the wind's going to be in that area. But it's a big deal. Wind loading is a huge problem. But if you look, the way they did these panels, the Solyndra panels, is they actually have tubes. These are thin film, they're tubes coated with thin film solar material. And the tubes are actually spaced about 1.5 inches apart. So when the wind goes through hits this, it just goes right through it. There is no wind uplift on this because it's not a sail anymore. The wind just goes right through it. So you could actually set this on a flat roof in most areas and not have to bolt it down or weigh it down or do anything. And that was pure genius in my mind. These were very, very easy to install. Normally it takes several people, several days to install all make all the penetrations to the roof, install all the flashings so nothing's going to be leaking, everything's waterproof, and then you have to put racking on top of that, and then you have to put the big heavy solar panels on top of that. And, it all takes a lot of time. But a system like this with the Solyndra, me and one other person installed 8 kilowatts of solar in one day, starting from a blank roof, because all we had to do was literally set these stands up and then set these frames of tubes on them, and we were done. There was no roof penetrations, no flashings, no racking, none of that stuff. So this did make things a lot easier, and I hope someone picks up the patent on it because it was a brilliant design. So that's some examples of thin film modules that are out there. And there's plenty of other ones out there, and I'm sure there'll be more companies coming up with new and better things all the time. But that's the thin film PV modules. So that's the basics on PV panels. And then the number 2 thing that you need in your system is an inverter or inverters. And inverters also come in lots of different flavors. There's lots of different types of inverters out there. The main one that probably is used the most on residential solar would be a standard residential inverter, which they usually call string inverters. And these are just plain small inverters that would mount on the side of a house. And this particular one includes its little DC disconnect there. This is an SMA inverter. But there's lots of different brands of these. And there's SMA, Solectria, Power One, Fronius, PV Powered, Advanced Energy, Keiko, there's dozens of them out there. So the inverter, again, remember, changes the DC power to the AC power. It also manages feeding power to the grid. It also usually keeps track of what the system's doing and tells you, okay, you've produced this many kilowatt hours today, and you've produced this many kilowatt hours since the system was turned on, and you're producing this many watts right at this moment right now. And that kind of information is usually going to be shown on the display screen here. And most of these inverters, too, have monitoring systems you can hook up to them, so you can send it all to the internet, and you can look at how your solar is performing while you're sitting at your desk at work. And you can see, I've got shade on my panels and my system's not doing very well, or whatever the case may be. So that's the standard residential inverters. These would typically output, 120 volt, 240 volt, 2 legs of 120 to make split phase power, just like most residential houses have. Now, the big problem with central inverters is that all the solar panels are connected together. You connect them in series to get the voltage you need, and then you connect those series strings in parallel to get the amount of power you need. So all the panels are interconnected with each other. And the issue you can have is if you have shade on just one of those solar panels, it's going to drag down the output of the entire system. It's kind of the effect of the least common denominator. The worst performing panel in the system is going to set the pace for the system, basically. So when you have one panel not performing well because it's shaded or because there's something wrong with it, which is rare, more often than not it's a shade issue, the system is not going to work very well. You could have half of one panel shaded and lose 75% of your system. It's not always going to be that bad, but it can happen, and it's one of those things, it's a common rookie mistake with installers, and I've seen it over and over again, where the system's installed and a few weeks later the customer realizes they're not getting the output that they're supposed to, and they find out that it's because there was shade on one of the panels, and the inverter wasn't being able to output as much power because all the panels were connected together, and they were all getting dragged down by the shaded one. So the industry stepped up and came up with a solution to that. And the solution to that is microinverters. Now what these are, a typical residential inverter can handle anywhere from probably, it depends on the inverter. Some can go as low as 6 panels, and some can go as high as 40 or even 50 or 60 panels. So you have one inverter for all those solar panels. You could have 50 solar panels on a house and they're all feeding a single inverter. And if one of those panels is shaded, the other 49 panels are having a problem because of the one shaded panel. With microinverters, you have one inverter per solar panel so that they are all acting completely independently. And if one solar panel is shaded, yes, that solar panel is not going to give you very much power, but the rest of the solar panels in the system are going to do just fine. So the microinverters, and this one is a picture of Enphase, which is probably one of the most well-known brands, but there are other brands out there, and there's even more coming soon. There's lots of companies trying to get their inverters to market and get them UL listed so they can sell them, because the microinverter is a very good solution to not only the shading issue, but if you have panels facing different directions, it's a good solution for that too, because they don't work very well on central inverters with panels facing different ways. So that's the microinverter. And then the third type of inverter is the commercial inverter. And really this isn't very different than these residential inverters, but they're a lot bigger and they can handle a lot more panels. You can get one inverter that can handle 1,000 solar panels without a problem. That's not that crazy big. There's ones that can even handle 2,000 to 4,000 panels. Now they're a lot bigger. This one here is about 6 feet tall and probably 4 feet wide, and I can't tell from looking at it, but it's probably like a 100K or a 95K inverter. You can also get ones that can go 250 kilowatts or 500 kilowatts, even up to a megawatt. Now if you're getting a single megawatt central inverter, the thing is going to be huge. It's probably going to be close to the size of a semi-truck. So, they're not kidding around with these big inverters, but the big difference between them, other than size and how many panels they can handle, is their output capabilities. This is typically going to output 2 legs of 120 volt power to feed a 240 volt split phase system in a house. This is going to feed 3-phase power to a commercial facility. So you're going to get either 3 legs of 277 volt for 480 volt power, or 3 legs of 120 that gives you 208 volt power. And there's also some other ones in between. There's a 3-phase 240 that it's usually older systems, but there's a lot of different types you can get into. But for the most part, it's going to be 208 volt or 480 volt power that's going to come out of one of these big inverters. So those are the inverters, and that's what changes the AC to the DC. I'm sorry, it changes DC to AC. Easy to get that one mixed up. So that's what the inverters, so that's the number 2 part of the solar power system. Now the third component we said was balance of system, or BOS, and that's going to include a lot of little stuff that you need. There's a lot of obvious things like, yes, you need wires because you're going to have wires to run from the solar panel to the inverter, and from the inverter to the main electric panel. So you got to have wires to conduct that power. Another thing that you need for the solar power systems is warning labels. They're required by NEC code. Most cities and counties require them as part of the inspection. They look to see if those are there. And then there's a few other things that we're going to get into more detail on. The racking is probably one of the most important ones. And the racking is going to be different depending on what type of mount you're doing. If you, for example, want to do roof-mounted solar, here's a picture of roof-mounted solar, you have to do what they call flashings to make sure that your roof is not going to leak. Because remember where I said there's a lot of wind load that we have to worry about. So we actually want lots of attachment points, and we want those attachment points going right into the roof racter, which means you have to go through the roofing material, which means it all needs to be properly flashed into code so that the customer's roof doesn't leak. And roof leaks is a problem in the solar industry. It's something that's gone on, and we're seeing a lot of roofers getting calls for people that got a solar power system put in 4 or 5 years ago, and the person who put it in didn't know what they were doing, and the roof is now leaking. And the roofer basically has to pull the entire system off the roof and re-roof and then put the system back. So you really want to make sure that the solar company you're working with is experienced and knows what they're doing with the roof flashings. And there's lots of different flashings that we use depending on what type of roof we're dealing with, the shingle versus shake versus tile. But that's the mounting for the roof. And then we just put the rack right on top of that, and then we clamp the solar panels down to the rack. You can see here these little dots in between the panels are the clamps that are holding them to this rail that's underneath them. You can see the rail sticking out a little bit at the end here. So that's a roof mount. Now another way to do a roof mount, if you don't want to put penetrations in the roof and it's a flat roof, which usually is going to happen on a commercial building, you can do what's called a ballasted mount. It's basically you just got to make sure that these solar panels don't blow away in the wind. So if you don't want to put holes in the roof to attach to the roof structure itself, you can actually do ballast. So you put in the panel on a rack like this that includes trays, and there's lots of companies making these. This one is the Unirac Rapid Rack brand, but plenty of different companies make different versions of this. And you put this down on the roof just like it is. You clamp the solar panel to it, and then you put down concrete paver blocks or cinder blocks to weigh it down. And the number of these that you need is going to be part of a bunch of engineering calculations based on the wind load, the height of the building, that kind of stuff. And the one issue with ballasted systems is the extra weight on the structure of the building. A typical solar power system is about 3 to 4 pounds per square foot of weight on the building. When you start putting in the ballasted systems, depending on your wind load, you're looking more like 9 to 10 pounds per square foot. So a lot of times you have to do some special engineering to make sure the structure of the building can handle it. So that's a ballast mount. Another type of mount is a ground mount. And this is a picture of what it looks like from the front. You can just see the solar panels mounted on a rack. And you can see this is the detailed drawing that we did for the permit department, where you've got, it shows the tilt of the rack, and it shows here the footings. Doesn't look like much right here, but these footings go down deep. Usually they're about 48 inches deep. And that concrete, all that concrete that's holding this into the ground is actually what keeps it from getting picked up, because the wind uplift on this is worse than even on a roof, because the wind can get right up under there and pick this whole thing up. But you can see how many posts there are in the ground here, and each one of those has 4 feet deep of concrete, and thing's not going to go anywhere. So that's what a ground mount looks like. Now, other stuff that you need some electrical components besides just wires. You need disconnect switches, which is part of the whole NEC code thing. Everything has to have disconnect switches. Part of it is for safety. Part of it so the electric company has access to turn off your system if they need to, or the fire department has access to turn it off if they need to. And so you have a DC disconnect, and this is the picture of the one that comes with the SMA inverter, but you can also get just plain DC disconnects that look kind of like this. So that shuts off the DC power, which is the power from the solar panels to the inverter. And most inverters include these now, so a lot of times you don't have to buy it because it's already going to come with your inverter. And then a lot of times you need what's called a string combiner, which I said that we're putting solar panels together in series, and then each one of those strings all need to be combined together electrically. And the proper way to do that is in a string combiner, where each string has its own fuse. Now, again, string combiners usually come with a small residential inverter as part of a DC disconnect. You can usually combine, anywhere from 1 to 6 strings, depending on the brand of inverter. Now, if you're using those big inverters and you've got, a whole lot of strings, oftentimes on those larger systems, you could have 100 strings going to your inverter. Then you buy the big industrial combiner boxes and use those. Now, another thing you need is the AC disconnect. which usually looks like this or something that looks like this, only bigger, depending on how many amps it has to be able to handle. And I always call these the Frankenstein switches because they're big clunky switches on the outside of the house, and they make a big clunk noise when you flip them. And I always make jokes about them being Frankenstein switches, but that's the AC disconnect, and that's going to be between the inverter and the main electric panel, and that's the easiest way to shut down the system. Most electric companies want this on the outside of the building where they can get at it in case they need to shut down your system so they can work on something. Another thing that you need with solar is grounding lugs or weaves, which are, it stands for washer electrical equipment bond, which is basically grounding equipment. And what this is all about is every metal part of the solar power system, all the solar panel frames and all the racking needs to be grounded for safety purposes. If a positive wire from the solar panel gets pinched between the solar panel frame and the racking, and it actually cuts the insulation on that panel, it could feed power to the entire rack. And if that rack is not grounded, now it's electrified and extremely dangerous. So as part of this safety for solar, we're going to ground every single solar panel. And you use grounding lugs or weaves depending on the circumstances and what the electric company wants to, and the city or county wants to see. So those are the grounding parts that we use, which is part of our balance of system. So that's pretty much it for solar. That's really all you need to make a standard grid-tied solar system work. And just to go over this is the wire diagram for it without just the basic main components. I didn't put any disconnects on this. But you've got the PV array, which is the group of solar panels, or PV panels. They're feeding that inverter. That inverter feeds the main service panel for the house or business. And then from that point, power is going to go to and from the utility grid. You'll be feeding power to the utility grid during the day when you're not using as much. And you'll be taking power from the utility grid during the nighttime when the solar panels aren't generating much, or any time during the day when you're using more power than your panels generate. And then from the main service panel, your AC loads in your house or building are getting fed. So that's a standard utility interactive system. Now, that is the majority of what solar companies are installing now. But since this is a general overview, we're going to talk about off-grid solar as well. So off-grid solar includes the same solar panel technology. The solar modules are exactly the same. We use the same ones for off-grid as on-grid. It's the rest of the equipment that changes. So we would also often call off-grid solar a standalone system because basically you have power without having to be connected to the electric company. So the system is its own separate thing. Usually anything that's off-grid is going to use batteries to store the generated power so that you can have power when the sun is not out. There are some exceptions to that, and we'll talk about those in a minute, but for the most part, you're going to have batteries in an off-grid system, unless you only want power during daylight hours. And then there are, as I mentioned earlier, the systems that can be on the grid but have battery backup. And how those work is they work as a grid-tied system when the grid is operating. And then if the grid shuts down, you lose your utility power for whatever reason, whether there's a disaster or just, somebody ran into a telephone pole and knocked out the power transformer. Then your system will suddenly turn into an off-grid system, operate in standalone mode until the electric company gets the power working again. And then your system goes back to acting like a grid-tie system. So those are kind of the in-between thing where you can get backup power. And basically your system's acting like a grid-tie system when the grid is on, and acting like an off-grid system when the grid is off. So it's kind of a in-between type of system. Now, there's a lot of different applications for off-grid PV, and some of them are more, people think of them more than others. For one, there's lighting. Lighting in places where there's no electricity. You've got billboards, parking areas, transportation areas like bus stops or train stops. Navigation and aviation aids. So, out at the airport in the middle of nowhere, they want to have some lights so that the planes can see them. They can use solar panels to run those lights. You have a billboard out on the highway in the middle of nowhere, and there's no power anywhere near it, but you want it to be lit up at night so people can see the advertising on it. I've actually done a lot of systems like this. When I first started in the solar industry, there really wasn't a lot of grid tie going on. I started with a company that sold mostly off-grid equipment. And, people would call us for, I want to light up a billboard, I want to light up a sign, that kind of thing, and we would sell those systems. And then we kind of saw the grid tie market blossom and come to what it is today, and everybody jumped on that bandwagon. But there still is some off-grid stuff going on. So you've also got specialty applications, remote cameras, train signals, security systems, and water treatment. Remote cameras is a big one. I've sold a lot of systems to people that either had security cameras, or another big one is wildlife cameras. The researchers put cameras with motion sensors out in the woods, so when an animal walks by, it starts recording, and they can watch the animals without the animals, being disturbed by human presence. Those are great, and the problem what they have is that there's no power out there. So, we put a solar panel up, either in a clearing or up higher on the tree where it's going to get some sunlight, and that solar panel charges a battery, which keeps the camera running. So that was a big one. And security systems is the same thing. You want security out at your, front gate, and, you don't have any power out there, you can just use the solar panel to keep the security camera running. And then train signals. There's a lot of train signals out in the middle of nowhere, again, that there's no electricity out there. Remote telecommunications. All those radio towers and things you see on mountains, and they've got the lights on them so the planes don't run into them, and usually they're repeater towers so that the radio stations have a longer range. Most of those are run off solar or some other kind of renewable energy because there is no power up on those mountaintops. I've actually sold quite a few systems that ran radio towers back when off-grid was really the only market for solar. Another more common one that people think about is off-grid homes. And these can be full-time residences or weekend vacation cabins. And, when sizing these systems, it's kind of a fun thing when people call up and say, oh, I want an off-grid house. And you say, okay, and they say, how much does it cost for a solar power system? And it's like, well, it really depends on what you want to run. I've talked to lots of people that lived off the grid without any electricity for years, and they finally got enough money together or whatever to get their solar power system. And it's a very exciting moment for them, and they get 3 solar panels, and they're just absolutely thrilled with it. And, they get a little bit of power during the day. Maybe they can put in a refrigerator or something else that runs on electricity but doesn't use too much, and they're happy as clams. I have other customers that are building a weekend cabin, and I asked them, I started to go through the list of what they were going to run so I could size the system properly. And I said, are you going to have a TV? And they said, yeah, we're going to have 3 TVs. And I said, okay, how many hours a day do you think those TVs are going to be on? And they said, oh, 8 hours a day. And I said, why are you even bothering to go live in a cabin for the weekend if you're just going to sit there and watch TV? But, those people basically wanted the house to run just like a regular house. They wanted a washing machine and a clothes dryer and a stove and all that other stuff. And whenever someone wants that, whether they're going to live in the house full time or whether it's just a weekend cabin, we start to go over some details about, off-grid solar and what you should do to make it most efficient. And one of the things you should always do is have all of the things that involve heat not be electrical. You should run them on propane or gas or something else. These things would be the stove, the hot water heater, the furnace, and the clothes dryer. Everything else is pretty easy to run on solar, and you really won't have to spend too much money on a system to run a house, even just like a normal house. Air conditioning gets a little dicey depending on how cold you want it and how much you run it. But if you keep those main loads for heating loads on propane or gas, it's going to make a big difference in how much solar you need. So, part of what we would do when people wanted the off-grid solar for their homes or their cabins is we'd go through a whole lot of, sizing questions and educating the customer on, exactly how that's going to work. And then the other thing about off-grid homes, especially if it's a full-time residence, you want some kind of backup power out there. You want some sort of generator. You can get a generator that runs on diesel or gas as backup, because there's going to be that time when it's cloudy for 2 weeks straight and you're not getting enough power to do the things you need to do in your house, and you can turn on that generator. And most inverters include a charger in them, the battery-based inverters, so it'll charge the batteries from the generator power, and then you can turn the generator off and you have power again for a while. Or if anything else happens to the solar, it's good to have a backup. So anyone who wants to live full-time off the grid, or even on a weekend cabin where they just don't want to live without power if it's bad weather, for too many days in a row, we would suggest they put in the AC generator. Another use for off-grid solar is there's some agricultural uses. Well pumps and irrigation is big, and remote electric fences is pretty big too. There's most electric fences now have a little add-on kit that include a solar panel and a battery so that you can have your fence charging without having to have it, have power running to an outlet somewhere. If you've got a huge ranch, that could get very difficult to get power out to all of your fencing out in the remote areas. And the well pumps is a big one, and irrigation. The way that these systems often work is these are the ones that would sometimes not include batteries. And you would only get power for your load when the sun is out. Now, if you are, for example, irrigating a field, this works perfect because you want the water to flow when the sun is out. And if it's raining, you don't want the water to flow because your field is already getting water from the rain. So it's kind of a perfect system for it to be on direct solar without any batteries because you only want the water to flow when the sun is out. So those work really well. Other off-grid applications is rural development, and this is mostly in the third world. And it's funny because they have this catchphrase that they use in a lot of countries. They say rural electrification. And basically, these are communities and villages off the beaten path that do not have any electricity at all. I worked with a charity group that I used to he'd sell equipment for and help them find volunteers and get freebie equipment from places. That they were a charity group, and what they did was they actually went to solar, or basically they put solar in and places like schools and that kind of thing. So the whole community, nobody had any electricity except the school, the little schoolhouse. And I heard some stories about having to carry solar panels either on their backs or on the backs of donkeys for 2 hours to go up a mountain because there were no roads to this community, and they put the solar in at the school there. So that kind of stuff is going on. Schools, churches, community centers, and healthcare facilities. A lot of the clinics, they need to be able to refrigerate the vaccines and that kind of stuff, and they need electricity for that. So that's another off-grid application. Consumer electronics, people don't think about it much, but calculators, radios, flashlights, solar phone chargers, that kind of stuff is, solar calculators have been going on for forever. Solar flashlights people laugh at because what do you need a flashlight when the sun's out? But really, you leave it out in the sun, it charges, and then you use it at night off the batteries. And then spacecraft, which is actually the original use of solar panels, and that's way, way off the grid. PV, really, the first application for PV that anybody saw as a reason to make PV panels was the space program, because they needed to get electricity for satellites and spacecraft. So those are some of the off-grid applications. And then here's just some basic wire diagrams of what these standalone systems look like. If you were running a solar well pump with no batteries, all you have is your solar panels, your PV array, feeding that DC load, that well pump. And if you had an off-grid home, it would look something like this. You would have a solar array feeding a charge controller, feeding a battery bank, and then you can run DC loads off that battery bank, or you can use an inverter to run AC loads. And then you could have an AC charging source, like I said, we recommend you have a generator if you're going to live off-grid for regular. And that's going to be charging through the inverter to feed your loads when the solar doesn't keep up with you. So that's the basics of solar on-grid and off-grid, and just some general resources that are good for everyone in the solar industry to know about. There's NREL.gov, which is the National Renewable Energy Laboratory. There's DSIREUSA.org, which is the database of state incentives for renewable energy. That's a great place to go and look if you want to find out what rebates and tax credits and that kind of thing are available in your state, in your city, and through your electric company. There's SEIA, which is the Solar Energy Industry Association at SEIA.org. And then there's NABCEP, and NABCEP is one of the most recognized organization that certifies solar installers and solar salespeople, and they are the North American Board of Certified Energy Practitioners. So again, my name is Catherine Kelso, and you can find more information at www.ambassadorenergycollege.com. Thank you.